know, we are learning something about integrals, and we are going to talk about integration by parts. Most of you must recollect what you have done from your higher secondary days, but I would like to say that most of you have not really understood what essentially goes on behind this technique of integration by parts. When I was in high school, it was told that if a product of two functions and one of them is integrable very easily, then there is something called integration by parts and you can just go through them. The issue here is that the idea actually comes from what happens when we take the derivative of two functions, derivative of a product of functions. So, you know that d of, suppose I have two functions ux and vx, and I am taking the derivative with respect to x. So, what do we have here? I have Vx into du dx plus ux into dv dx. More generally, you can write uv dash is vu dash plus uv dash. So, again if you write in terms of the differential language, which we had taught you in the last class, you just see this. So, if you go back to the differential language, then we have the following, that d of u v is equal to v of du plus u of dv. So, when you integrate out, so you have uv is equal to integral v du plus integral u dv. So, this would imply that integral of u dv is equal to uv minus integral of v du. So, let us start with a simple example and let us see where do we really reach. By the way, I am again taking the examples from this lovely little book which I have personally have enjoyed and will recommend to everyone the book. In fact, I want to show you in this series, if you do not know, this is called A Cartoon Guide to Calculus. Please, this is not a, it is fun book. I do not think you can learn anything without having fun in it. So, here is a book where you learn deeper things and have absolute fun, and this should be a book which every engineer or scientist can keep in their desk. This is just fun, you get all the basics and all the very deeper ideas told to you in a very interesting and fun way. Now, I remember when I was a kid and then I was taught, okay, suppose you have a situation like this ux vx into dx, then what you do is you basically, suppose you can easily integrate Vx. So, you integrate Vx and then you subtract, which is essentially this. Basically here I have uv dash. So, here if I take v dash dx, it will give me nothing but v. So, basically instead of u dv, I am writing dv as vx dx. So, this is exactly the formula. Now, let me see what I will tell you what I was taught. So, you take the integral of ux, this whole thing, into the integral of vx dx into dx. So, this is your du. What is du basically? So, can I get this formula? This was what I was taught in my high school. I never understood what was happening, but of course I understood it much later, that it was just from this whole thing. So, once you have the idea of differential clear, everything becomes clear to you. Now, let me see how I translate this whole thing. Now, instead of this one here, I just run, so integral u dv. So, instead of u dv, I write dv is written as v dash dx. You see, I have here written in terms of v and u, but here I am writing the same thing essentially in terms of x, because u and v are essentially functions of x. So, u v dash dx. So, see here, just remember the formula, dv is the differential of v is the derivative of v with respect to x into a differential of x, which is dx. So, that is equal to, when you do this, u v, of course here ux vx, because this u v is now what is v? V can be in fact written as integral v dash dx, because v dash dx is nothing but du when you dv. So, when you integrate dv you get v. Now, what do I have is now minus, what is my du? Du is nothing but, du can be written as the derivative u dash x, the derivative of u times the differential of x, and then I have this part, I have to look at this part. So, what is in v? V has come to be, v can be written as nothing but integral of v dash dx into du. Du is what? It is u dash, which is du dx, which is u dash into dx. So, u dash is nothing but du dx. So, this is the formula which I was taught by my teachers without giving any reason, is exactly this formula, which comes out simply from the product formula which you have learned from the which is very simple to show, for how to take the derivative of the product of two functions. Now, once we have this thing in my mind clear, let us give you some simple examples, not simple but very interesting. See, these are the problems, you start really looking at these problems when you do not have, you cannot immediately say, okay, I can find a function whose derivative is the given function under the integral sign. No, if you cannot do that, you really have to think about integration by parts. Your substitution method does not work, other methods that you know possibly about integration does not work, then what are you going to do? So, here we are going to really concentrate on taking examples from this lovely book. So, let us take the first example, number 1. So, I have to integral, I have to find the integral of 3x square log x dx. Now, if you think of it, nothing seems to work. So, if it does not work, what I am supposed to do? Okay. So, let me see if I have a candidate of something like dv here. Now, if you look at 3x square dx, 3x square is a function which is y is equal to 3x square, y is equal to x cube, then 3x square is the derivative. So, the derivative of the function into dx is the differential of the function, it is d of x cube. So, if I go by my formula, which I am again keeping on the side, if you forget it, is integral u dv is equal to u v minus integral v du. So, this one, once you have this thing, so you know that my choice of v is now known. So, my v must be this one. So, my v x is equal to x cube. So, if my v x is equal to x cube, I have u dv. So, I have 3x square dx is my dv. So, it is dx cube. So, this actually means my ux must be log x. Okay. So, my dv is, of course, already I know 3x square dx, and my du is 1 by x dx. Now, I am going to apply this formula. So, integral 3x square ln x dx is equal to, now let me see, you have u into v. So, you have x cube ln x minus v, that is x cube, into du, that is 1 by x dx. So, you have x cube ln x integral x square dx. So, that is x cube ln x minus x cube by 3. Of course, this is plus c at the end. Now, that is the whole game. Now, do you believe this, that this result is correct? So, if you do not believe it, okay, let us take f of x to be x a cube ln x minus x cube by 3 plus c. So, take the derivative of this. So, this is a product form. So, you have 3 x square ln x plus 1 by x x a cube minus x square, because it will be 3 x square by 3. So, this will give you 3 x square ln x, and voila, this is the integrand, and hence I have done the correct thing. This is the correct one. So, let us take our example 2. So, this is the fun integral. By Jove, it looks pretty interesting. You cannot think of a function immediately whose derivative is log x. Of course, those who study optimization and convex analysis at a higher level, very high level, they would immediately realize what it is, because they use the antiderivative of this function day in and day out. Okay, so, but where is my dv? That is problematic. So, let me do, so it must be u dv, again the formula, forgetting, okay, write it down. Every time I will write it down, integral u dv is equal to uv minus integral v du. This formula should become a part of your game. So, here you have the u, maybe which I can take at log. What is dv? Let me just say dv equal to dx. Basically, I am taking vx is equal to x, and ux I am taking as log x. So, if I use this formula, integral log x dx is equal to x log x minus integral, what is v? V is x, and what is du? Du is 1 by x dx. Voila. So, there is x cancels. So, x ln x minus integral dx, and you know what the game is. Take the derivative and we will see the answer comes. So, this is a beautiful result. You would appreciate mathematics much better if you try to find some beauty in this. Isn't it so amazing? This c has to be always put in. I do not like this c, it looks very clumsy to me, but somehow in mathematics you also have to take into account the truth more than anything else. So, here is this lovely thing. Now, get on to the next one. So, isn't calculus fun? Calculus is truly fun, let us try it out. Okay, what about, say, I will do two integrals, one with the help of another. So, example number 3, integral x into cos x. So, what do you want to substitute? So, you want to take t equal to cos x, u equal to cos x, and you have, so your du would come in terms of sin x. So, there is no way to substitute anything, there was no way to do any issue. So, what you can do is, there is no way to do anything. In these trigonometric integrals are the hallmarks, trigonometric and logarithmic integrals are the hallmarks where you immediately know that integration by parts is my tool. There is no other tool I can really fend for. Now, let us have a look. So, integral x into cos x dx. So, what are you going to do? If I look at it very carefully, the derivative of sin x is cos x. So, cos x into dx is exactly d of sin x, the differential of the function sin x. Wow, so this is your dv, you already know. So, your v is actually sin x, so your vx is equal to sin x. So, what is your u? So, your u is x. So, because your dv, so this must be u. ux is x. So, integral x cos x dx. So, again repeat in your mind, integral u dv is equal to uv minus integral v du. Once you know this, you will immediately understand the game. So, how neatly things come. So, you now know which is u and which is v. So, x sin x minus integral v du, you know what is v, v is here sin x, and you know what is u, you know what is du, du is equal to dx. So, it is x sin x minus, obviously integral of sin x is equal to minus cos x, because minus derivative of minus cos x is sin x. So, it will become plus cos x plus c. Now, how does it help in some other integration? Let us see. You have integral x square sin x dx. Now, once I do this, I want to find this integral. So, again I will question which is my u and which is my dv. So, you know that the derivative of minus cos x is sin x, right. So, dv, if I take dv is equal to sin x dx, which means what, my my vx is equal to minus cos x, my dv is actually this, my dv is this one. So, which means my ux is equal to x square. So, it is again integral u dv. So, integral x square sin x dx is equal to, very funny what to do. Now, it is u and v. So, it is minus x square cos x minus integral v du, your v is again minus cos x, and what is du, it is 2x dx. So, it is 2x dx, good. So, it will become minus x square cos x, minus minus comes out, 2 comes out. So, it is plus 2 integral x cos x dx. Oh, by Jove, this is already done here, we have already done integral minus cos x dx. So, again just put in the value you have already known. So, this will be plus 2 x sin x plus 2 cos x plus 2 c is same as c, let us call it c dash, does not matter. So, here is the game. So, here we have computed. See what happens that there are a lot of integrals which come in the form integral xn sin x dx or integral xn cos x dx, and then these integrals are the one for which integration by parts is the best way to go about. So, I will end by taking one more example, the last one I guess, I think the 6th one. If I have not numbered the previous one, let me number this as 4. So, this will be the 5th one. So, 5th one is integral sine square x. This is little tricky, sine square x, what is my du and what is my du? Now, how do I think about it? Sine square x, I cannot think about any functions whose derivative is sine square x. Can you think about? No, I do not think so. So, let us break it up and write it as sine of x into sine of x dx. Let me think this as dv. Let me think that dv is equal to sin x dx. So, my v, what should be my vx? It should be again just like the previous one minus cos x. So, my ux is equal to sin x. So, my du is equal to cos x dx. So, this is the only information I have now. This is a guesswork, I am just trying to break it up. So, now again apply the formula, again if you forget, just repeat in your mind, u dv is equal to uv minus integral v du. If you can repeat this in your mind, you have done a major thing. Okay. So, it is sin square x dx would be minus sin x into cos x, that is minus cos x into sin x, plus integral cos square x dx. Oh boy, what to do? Again an integral of a similar sort. So, why not we do write cos square x as 1 minus sin square x dx. So, what I will get is minus sin x cos x plus integral dx minus integral sin square x dx. So, you take the sin square x to this side. So, 2 of integral 2 times integral sin square x dx is equal to minus sin x cos x plus x, right, plus c. So, integral sin square x dx is equal to half of minus sin x cos x plus x plus c. C by 2 you do not have to write, c by 2 is some other constant plus c dash. And the French would say voila, that is it. So, with this we are going to end our talk today, and I hope you have enjoyed this little session. We had an integration by parts, and in the next talk we speak about how to actually effectively use your idea of the definite integral. We give some examples, right. Thank you so much and have a good evening.